Good morning, everybody. So today we are finishing up Unit 5, and we're just going to add on a few simple little ideas. It's not like a brand new concept that's going to take, forever to figure out. It's just like, hey, by the way, you might want to think about this. You might want to think about this. And some little tips to help you in case, you see something weird on a graph, or you happen to have no zeros at all yet. You can find maybe some tricks to get through this stuff. Okay, so our warm-up is just the same old stuff. We're just going to solve some equations. This is the big thing for the unit or for the whole course, because polynomials are essential. Solving cubes and squares and things like that. That's a pretty basic skill. Okay, so what do? Of course, you start by graphing it. So I assume maybe somebody's graphed it already. Anybody find a zero yet? Of course, it's not equal to 0. If you look at it, it's equal to 36 originally. So you got to move the 36 over first. Always graph and vector compared to 0. If you don't, you're not going to get the right answer. You're just wasting your time. 4. Got to vote for 4. Okay. I believe that. That seems very plausible based on the numbers involved. But again, I'd like confirmation from somebody, just because I don't want to go off on a tangent and do it wrong. And you should be just as careful on the test. You should make sure you're doing second calc. You should be sure you're doing left bound, right bound, and being very sure that the 0 is where you think it is. And I will throw some on the test that'll kind of mess with you. There might be one at like 3.13, and you might eyeball it and say it's 3 and do it all wrong. So make sure you're doing second calc, because I will be testing that you're not just looking at it. Hoping. 4? Anybody? 4? Got some head nods for 4. Okay. So we're kind of agreeing on 4. I only need 1. Because every 0 I get, I can get down a degree. So it's only a third degree. So just 1 0 will get down to a second degree, a quadratic. And if push comes to shove, we can always do quadratic formula on it. All right. Well, if 4 is a 0, then x minus 4 is a factor. So x minus 4 must go into this thing. And it's times something that I don't know. And the result is going to be the original thing, x cubed. And again, the concept is, if this times the blank is the original, then the original divided by the x minus 4 must be the blank. So we are going to take the x cubed minus 4x squared plus 9x minus 36. We're going to divide that by x minus 4 real quick. And we're going to see what else is left buried inside this thing when I divide them. So you get yourself an x squared, x cubed minus 4x squared. They're the exact same thing here. So when you subtract them, there'll be nothing left, which is great. So there's nothing to deal with, but you still got these other things to bring down. So this 9x minus 36 still needs to come down. And clearly, x times 9 would give me 9x. And as desired, the remainder is a big old 0. So I'm 1,000% confident your guys' answer that 4 was a 0. And the other factor that goes into this, therefore, is x squared plus 9. So there's the other factor. And that's what all that work is for, just to get those next line and write down what goes in that blank. And then clearly the answers are x equals 4 from this one. We knew that one. That was a gimme. And the other 2 for this third degree is buried inside this thing. So let's go work on this x squared plus 9. When is that 0? Well, if there's no middle term, probably the fastest thing to do is just move the 9 over. Take a square root. Don't forget your plus or minus. And obviously, since it's a negative and you're taking a square root, there would be some kind of I thing involved. And the square root of 9 is 3. So the final answers for those are plus or minus 3i. So there's all 3. 4, 3i, and negative 3i. And that should be always what you keep in mind, because for a third degree, you should have 3 answers. So if you're on a test and I give you a third degree and you have 2 answers, you did something wrong or you missed something somewhere. All right, let's try it again. Number 2 today is saying x to the 4th. Plus 13x squared, I know what's going to happen on this one, plus 42 equals 0. Why don't you try to factor that? Yeah, I completely agree. I can tell by looking at what's buried inside this thing that, yes, this thing will have no zeros. So this is one of the freak times, okay? 99% of the time, you're going to find a 0 and be able to do what we just did. But this one, we got nothing to go on. So we got to go back to some old skills. Anybody see any tricks or old factoring techniques that we might be able to use on this thing? It's a certain form. God's exact. I love it. I love you. So yes, the first exponent is twice the second. This is a quadratic form. This is secretly some kind of quadratic. The first one, x to the 4th, is x squared squared. Okay, x squared times x squared would be x to the 4th. And then this one's, of course, just 13 times an x squared and a 42. So it looks just like a quadratic, just not with x's, with x squareds involved. So we can factor this. And this is the kind of stuff this is why they taught you that stuff in that one section. You know, why do we learn the difference of cubes and grouping and all this stuff? Because once in a while you need them. Once in a while is the only tool you got. But since it's a quadratic with x squared, we're going to put x squareds in here. And the two numbers that multiply to be 42 and add to be 13 are 6 and 7. So it's all factored out now. X squared plus 6 and x squared plus 7. And I can solve these. Okay, these are quadratics. They are second degrees. We just did it in the last problem. For this one, again, if x squared plus 6 equals 0, there's no middle term. I would just move the 6 over. Take a square root. Don't forget your plus or minus. It's the square root of a negative, so it's I. So plus or minus square root of 6, I. And then you got the other one, and I think you can probably just guess what the answers are for this one. It's going to be identical work. It's going to be x's plus or minus the square root of 7, I. And for either one of those roots, there's no perfect squares that go into them. 4 doesn't go into them. 9 doesn't go into them. So we're done. There's 4 answers. We did find them. But we couldn't rely on the old technique of graphing it. And that's kind of the moral of the story here. Once in a while, there is something to get you out of the woods and figure out what the answers are, even though you have nothing to go on graphically. But usually there's something to go on graphically. Okay, last one, number 3, we have 6x cubed. Ooh, it's got a 6 in front. Plus 5x squared. And minus 81x. And minus 140 equals 0. It's just set up for you, equal to 0, ready to go. It's a cubic, so I need at least one clean 0. I got to vote for 4. That is a plausible 0. That is possible. There are a few other weird things you can do to look at the numbers, by the way, and kind of guess what might be the zeros, but it's a minor thing, so I won't bother teaching it to you. Confirmation of 4 from anybody? Yeah, 4. Okay, so everybody's saying 4. Okay, so x minus 4 goes into this thing. How many times? I don't know. That's why I'm going to do some long division. So here we go. 6x cubed plus 5x squared minus 81x minus 140 divided by this x minus 4 known factor that goes into it. Let's see what we get. X times 6x squared would give me 6x cubed. So 6x squared times this divisor would be 6x cubed minus 24x squared. And really watch the minus negatives. I'm sure you're seeing your own errors and things like that as you do them. You need to rely on a calculator, type in 5 minus negative 24 to get the answer, then do that, because I'd rather you get it right than sit here and try to do the mental math. But you should know that 5 minus negative 24 is 5 plus 24, which is 29. So there's 29x squared after that subtraction. Bring down the other junk. This is not looking good, actually. It's looking really bad. Okay, well, let's see. 29, obviously, it's going to be a plus 29x, right? And 29x times x is 29x squared. 29x times negative 4 would be 116. So that's going to be a negative 116x. Gross. These are getting kind of big. I'm starting to not trust my own mental math. So just to be paranoid, I'm going to double check that. 29 times 4, yes. And negative 81 minus negative 116, to take the thought out of it, is just 35. So you have a 35x left when you're done. Bring down the other junk and start again. So clearly, x times 35 will give me 35x. So I'm going to have a 35x down here. I'm going to pray that 35 times 4 is 140. And if I double check that, yes, it is. 35 times negative 4 is negative 140. And as desired, it better dang well be 0. If my remainder ain't 0, I ain't doing it right. So this is the weird thing that's left. So, okay, 6x squared plus 29x plus 35. That's the other factor. Definitely, remainder was 0. And then to finish it up, let's see here. Well, clearly one of the answers is 4 because you told me that. And the other two are buried in this quadratic. This looks like a pain in the butt to factor. We probably could, but I'm not going to waste my time. Let's just go right to quadratic formula. I don't like to think. So negative b, negative 29, plus or minus, I'll just do the whole discriminant at once. B squared, 29 squared, minus 4 times a, which is 6, times c, which is 35, is, 1. That's nice. Okay, so the whole discriminant turns out to be 1. Wonderful. And the square root of 1 is just 1. Really no reason to write square root of 1 right there. So we got negative 29 plus or minus 1 over 12. Now, it's a nice clean number like 1, you should keep going. You know, can I figure out what negative 29 plus 1 is? Yes, I can. Negative 29 plus 1 is negative 28. And negative 28 over 12, that's one of the answers. Negative 28 over 12, which can be reduced because 4 goes to both of those. So if you divide them both by 4, you get negative 7/3. So there's one answer. That's a lot cleaner than negative 29 plus 1 over 12. And you should probably go the other one, do the other one also. The negative 29 minus 1 is negative 30. So the other answer will be negative 30 over 12, which again does reduce because 6 goes into both of those. And you get negative 5/2. So a couple weird fraction answers there. But so what? It is what it is. There's 3 answers. There's a third degree. Life is good. And that's kind of the main point of that. All right, let's get going on the last lesson of the unit. Here's your LGs for the day. Next week when you come back, we'll start reviewing for the test. Test will be late in the week next week, Thursday and Friday, 2-day thing as usual. It'll be over units 4 and 5. Units 4 is very much about the graphs of polynomials. And unit 5 was very much about solving equations with polynomials. I actually think you'll do pretty well. I think you're doing pretty well in this section. Would you kind of agree? This is the hard one, and usually people struggle with this a lot, but I think you guys are doing a pretty good job. So I'm cautiously optimistic. I've had my heart broken many times, though, so. I'm like a battered wife. This time it'll be different.
Reminds me of the Cards Against Humanity card. Like my abusive boyfriend, he's really not that bad. When you get to know him.
You don't understand what we have, man. All right. So this is about the fun. This is fundamental theorem again. It's really not like something brand new. I'm just going to add on a few simple ideas, and then we're going to call it a day and let you guys work and practice some more that are kind of like this with a few more tricks under your belt, which is nice. Okay, here's your new homework, 5.4. Take a minute, write that one down. It's due a Tuesday. It's the last one that'll be assigned online through the textbook, etc. When you come back next week, I'll have a review packet for you. You know the drill for tests. This one's not due till Tuesday. When we come back Monday, I'll start reviewing. I'll hand out your review assignment. Your review assignment we'll do on Thursday. You have 3 days to review and prep and all that jazz. 5.3 is due today. Homework 5.4 due on Tuesday. 29 through 43 all, and 46 through 51 all. So that's a decent chunk of problems. They won't take forever, but they don't take no time either. So pace yourself accordingly. All right, here we go. Section 5.5. Let's do this thing. Burr, burr, burr. Title today, Roots and Zeros. Section 5.5, Roots and Zeros. A lot of this we kind of already covered in the last section, but there are a few key terms I would like you to write down and really try to understand what they're saying because it's going to help you out sometimes. The first thing, blah, 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 we already talked about this stuff. I would like to write down a key vocab term for you, and it's called multiplicity. Write this one down. Multiplicity. It's not just a 1995 Michael Keaton movie. It's also.
Did you ever get that reference when you make it?
Nope, but I like it. It's for me. Multiplicity. The exponent. A factor is raised to when a polynomial is in factored form. It's actually a really easy idea. What it represents, oh, that's a whole other thing. Oh, man. So I'm going to give you something that's kind of really long, and because the point isn't that it's long, is that the things are buried inside of it right here. So here's this long thing that's already factored for you. You got an x minus 2. You got 7 of them. It's a lot. You got x plus 4. You got 3 of those buried inside of here. It's all factored out nice and pretty. And the multiplicity is basically the exponent. So here's how you would write the multiplicity of this. First of all, the multiplicity is associated with the zeros. Now, if you look at this factor, what makes this 0? 2, right? 2 makes this 0. So I would say that 2 is a 0 with multiplicity. And the multiplicity just means how many times is it there. There's 7 of them. So you'd say it has a multiplicity of 7. This one, -4, is a 0, right? I'm just going through and seeing what makes them 0, just like we always do. But I'm just giving a fancy name to the exponent. So the -4 one, that has a multiplicity of 3, because its exponent is 3. It's there 3 times. So multiplicity is just really saying what? How many times the factor is there. And same thing with the other ones. 5, it's a 0 with a multiplicity of 2. There's 2 of those x minus 5s buried inside this thing. And -9 is also a 0 with multiplicity of, again, 7. So multiplicity just means how many times the factor's there. And how many times it's there is really just the exponent, right? So that's why I just said that's the exponent of factors raised to, but that's how many of those factors are in there. Why are we introducing such a weird term? Here is the main thing I want you to know about multiplicity. Here we go. If a 0 has even multiplicity. So if you have a factor in there that's squared, or to the 4th, to the 6th, or even any even exponent, then the graph will bounce off the axis at that 0. On the other hand, if a 0 has odd multiplicity, then the graph goes through the axis at that 0. It's a lot of wordy stuff, but when you get down to it, you see a few examples, it ain't going to be that bad. Yes. So just by looking how many times the factor's in this thing, if it's there an even number of times or an odd number of times, I know what's going to happen on the graph at those zeros. There's 2 possibilities when something has a 0. Either it goes through it. Here's a spot on the graph where it goes through, correct? Goes right through that 0. Or it could come down and just bounce off of it right there. So if I saw something with an even multiplicity, I know it's going to bounce. If I see it with an odd multiplicity, I know it's going to go right through the axis. That is going to be quite a lifesaver for you right here. And you can draw some rough sketches of things based on that. So here's what we're going to do. I'm going to give you something like this. Here's your function. It's going to be all factored for you. Let's make it x minus 2 cubed, x plus 5 squared, and x minus 3 to the 8th, for example. Before we get started, and the point of this is you should be able to write a rough sketch of what this graph looks like. I know it looks really complicated, but you should kind of have an idea of what this thing looks like based on the multiplicities and what this degree is. Now, right off the bat, what degree is this? This is a what degree? This is a cube. Do you know this is a cubic? Because this is an x kind of thing to the 3rd, right? This is kind of like an x to the 3rd. This is kind of like an x to the 2nd. Would you agree? And this is kind of like an x to the 8th. What's a x cubed times an x squared times an x to the 8th? Well, add the exponents. What do you get? You get 13, right? This is going, if you distribute this all out, guess what it'd be? It'd be something x to the 13. There'd be a whole bunch of other crap too. I don't want to deal with that. We're not distributing all that out of the numbers. But do you see why it'd be like an x to the 13 thing? I'm just adding up the exponents. Now, since we're going to start reviewing for our test next week, what does a graph of x to the 13th or an odd power look like? It starts down here. Do you remember the stuff? And then it kind of goes up here. So I know right off the bat that this graph is going to start down here. It's going to do some stuff, but then it's eventually going to go up here, because I know that because it's like a 13th degree polynomial. Now you can spot the zeros on this thing. What makes that 0? 2, right? So right here at 2, I know it's going to cross the axis. Likewise, this one has a 0 at -5, right? So at -5, 1, 2, 3, 4, 5, there will also be a 0 where it hits that axis. And the same thing here at 3, there will be another 0 right there. And based on the multiplicities of these zeros, I can figure out whether it's going to go through that spot or bounce off of it, and the whole thing will link up and be nice and pretty. So let's go right through the list. The first one I'm going to hit is -5. Would you agree? Okay, so at -5, the multiplicity, the exponent, is even, right? So what does that tell you? If you have an even exponent, what's going to happen? It's going to bounce off the axis. That means when I hit this number, I'm not going to go through. I'm going to bounce right off of it. Come back down. Got to bounce when it's an even. The next multiplicity I would hit would be the one at the 2. Would you agree? Well, let's look at what happens at the 2. That's raised to an odd power. What happens with odd multiplicities? It's going to go right through the axis. So when I come, so I got to curve back around to get to it, but I'm going to go through the axis right there. Then the next one would be at 3, correct? If you look at the one that was associated with the 3, here's where the 3, 0 was, right? It's raised to an even multiplicity. So again, if it's even, what's it going to do? It's going to bounce. So this thing is going to come down, but it's going to bounce off that axis. And look at that. It's going to link up with the end behavior just like it should. So this is a very rough graph. Of course, it doesn't look exactly like that. Not the scale be stretched and stuff like that. But this is the nice outline of what this thing looks like. If you graph this thing, it'd come up, it'd bounce off the axis, it'd go through there, it'd bounce again, and it'd go up like that. Let's try another one. Example number 2. Let's say f of x is, oh, I don't know, x plus 7 to the 4th, and x minus 5 squared, and x plus 1 to the 1st. I don't even know why I wrote to the 1st. No. All right, here we go. Can you tell me some zeros? This is a 0 at -7, correct? So -7, 1, 2, 3, 4, 5, 6, 7. We know it's going to be a 0. This one has a 0 at 5. So 1, 2, 3, 4, 5. There's going to be a 0. And the last one has a 0 at -1. So it's going to cross right here at -1. All right, now I'm going to draw it. It's going to bounce and stuff. But where do I start? Do I start up here? Do I start down here? Where do I start? That's why you look at what degree the whole thing is. So this is like a 4th degree, right? And this is like a 2nd degree. And this is like a 1st degree. So altogether, 4 plus 2 plus 1 is what? 7? Which is an odd degree. So again, just like the last problem, what's an odd degree look like? It starts down here, and it goes up here. So it's going to be the same kind of thing. It's going to start down here and end somewhere up here. You don't have to draw the arrows right now, but I like to get them out of the way because now I know start down here. I'm going to go up to this 0. Now I'm going to either go through it or I'm going to bounce. I don't know, depending on what the multiplicity is right there. Yeah, -7. That one's got an even multiplicity, so it's going to bounce off of it. So it comes up, bounces off of there. I got to curve back around and get to this guy somehow. At -1, now that's raised to an odd multiplicity, correct? So that one's going to go through the axis. So I went through the axis. I'm going to have to curve back around. Now I know without even looking at the equation that this thing's going to have to bounce because it can't go through, or else I have to go through again. So I bet you this has an even multiplicity. I'm going to check my work. Oh, look, yep, it's raised to a even power, right? So right at 5, it's going to bounce off and hook back up like that. So there's 2 ways to go with it. Number one, if you got something factored, can you know what the graph looks like? Yeah, you can. But also, can you go the other way? So if somebody says, let's say you're doing your work right now. This is very much like the last section. And you graph it, and it does something like this. And it crosses at -7, and there's a 0 here at 2. What are the factors that go into this? Well, you already know that x plus 7 would be a factor for this, correct? And you already know for this one that x minus 2 would also be a factor, right? But here's the gem, ready? This one bounces, doesn't it? That means it can't be there just once, because if it was just once, it would go through, right? That means it's there at least twice. So there's not just one x minus 2 buried inside that thing. There must be another x minus 2. So when things bounce, it's not just one factor, it's two of them. So when you see a graph like this, if you're trying to do the last section and you see it has a 0 at 2, and you divide by x minus 2, you might be saying, well, I can't do anymore. Yes, you can. There's another x minus 2 inside this thing. And that's the key thing for this multiplicity. So if you see it bounce, you know the factor is there twice. And if you see a factor is raised to an even power, you know it's going to bounce, vice versa. Bouncing means it's there an even number of times regardless. Make sense? Questions over anything? All right, that's multiplicity. A couple other dumb little topics today, nothing too exciting. Let's see here. All I want to touch on, there's one other thing I want to touch on. That's it. Write down this bottom box. That's it. So multiplicity was the big thing today. There's a minor other little thing I'd like to bring up. One other little thing. And it's actually kind of obvious if you think about it. But you might have noticed a lot of the times when we're doing this work, something eventually turns into a quadratic. We do all this work, we factor things, blah, blah, blah. And we see a lot of times we're getting down to some kind of quadratic where I have to use the quadratic formula on it. And you should know from your quadratic formula, when you get a complex number out, say 2 plus I, you also get its conjugate out. And that was way back in the day with discriminants, when the discriminant was less than 0. So they gave two complex conjugate pairs. They always come in pairs. You have 2 plus I, 2 minus I is also a 0. Well, this is the same thing with polynomials. So if somebody says that 3 minus 4i makes something 0, automatically you know that 3 plus 4i, its conjugate, also makes something equal to 0 right there. And the reason they might want you to know that is because they're going to give you a few problems kind of like this next one. And I'll wait a minute while you write, and I'll do that. I think we're good, actually. So let's do this. And I don't like their examples. I'm going to do my own. Okay, so here's what we're going to do. A lot of times textbooks like to give you this. They give you zeros. So they're going to say, okay, zeros are given by 4, 5, and maybe 3 minus I or something like that. And they want you to go the other way. Usually I give you a big polynomial and you factor the heck out of it and you figure out what the zeros are. Well, can you go the other way? If you know what the zeros are, could you turn it back into a polynomial? And the answer is yes, you could. Because if you know 4 is a 0, then x minus 4 goes into it, correct? You know 5 is a 0, then x minus 5 is a 0. And I know that the complex one is uglier, but the same concept holds. If this is a 0, then x minus it is a factor. And note that parenthesis I put on that thing. It's always x minus it. And if I'm minusing a couple things added together, subtracted, I better put them in parentheses. But the point of the last slide is, if you know 3 minus I is a 0, then you secretly should know that 3 plus I is also a 0. That was the point of the last slide. They give you a complex number with i's in it. They're only going to give you 1. Because they want you to understand that you have 1, you secretly have 2. You have 1 and its conjugate. So again, whatever the 0 is, x minus it's a factor. So x minus 3 plus I, all of 3 plus I, would be another factor right here. And unfortunately, what they would want you to do now is to distribute all this out, which would really suck. We're going to do it, though. I'm going to distribute these in pairs. I'm going to do these two. I'm going to do these two, put them all together, clean it up. It takes some time, but, you know, that's what they want you to do. So the first two, I won't go through the details because it's pretty straightforward. If you distribute out those first two together, x minus 4 times x minus 5, it would turn into x squared minus 9x plus 20. Hopefully distributing that out ain't so bad. I'm going to go nice and slow on this second one because it's got parentheses and minuses and all kinds of stuff. In fact, I might want to take a moment and just clean these two up before I distribute it out. So this has a minus both of these, correct? So if I distribute the negative in, this is really x minus 3 plus I for the first one. And the second one, if I distribute the negative in, it's x minus 3 minus I. And I just did that for a second because, you know, it's a little cleaner to look at. Parentheses and minuses floating around, it's all good. And I still need to distribute these out. Now, this is going to be the nice thing. You know what happens with conjugates? Usually things clean up to be nice and real if you have conjugates. And that's what's going to happen on these two. If I'm patient and distribute these two out together, I'm going to get something nice and real, and there'll be no i's left. So here we go. Lots of distributing to do. X times x is x squared. X times negative 3, negative 3x. And x times negative I, well, it's negative ix. Moving on to the negative 3. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. And negative 3 times negative I is positive 3i. And lastly, distributing the I out, I times x is ix. I times negative 3 is negative 3i. And I times negative I, I'm going to go slow again, just like back in the day. Positive times a negative is a negative. I times I is I squared. But we should know what I squared is. Negative 1. Okay, so this is a big, ugly thing, but we're going to clean it up a little bit. So let's see what's inside of here. Now, check out the magic. This is so cute. Anything with i's, just i's, not I squareds, will go away. In fact, you see a negative ix right here? But I also see a plus ix. So what do? They cancel out, right? I see a plus 3i. But I also see a minus 3i. So these will cancel out. And you see what's going to be left is x squared minus 3x. And, oh, not 3x, is altogether 6. Would you agree? There's a negative 3x and another negative 3x. So I can put those together. Why not? You know, right here, might as well put them together. X squared minus 6x. Okay, so we got this guy done, this guy's done, this guy's done. What's the only thing left? I got a 9 and a minus I squared. And you told me I squared is negative 1, right? So this is negative 1, better known as plus 1. And 9 plus 1 is 10. So it's taking a lot of time. Problems like this kind of suck. It's an easy concept. If these are zeros, then x minus them are factors, but distribute it all out. And we're not done. I'm not done until I have this big long thing without any parentheses. So we got to go one more time. We got to distribute all this junk out. I don't need a parenthesis. I don't know why I put that. Okay, so x squared times x squared is x to the 4th, right? X squared times negative 6x is negative 6x cubed. And the x squared times the 10 is 10x squared. And the x squared has been distributed. Moving on to the negative 9x. Negative 9x times x squared is negative 9x cubed. Negative 9x times negative 6x. Well, negative 9 times negative 6 is positive 54. And x times x is x squared. And the negative 9x times the 10 would be negative 90x. So there we go with that. And then one more to go, 20. 20 times x squared would be 20x squared. 20 times negative 6x is negative 120x. And 20 times 10 is obviously 200. So it's all been distributed out. Only thing to do left, combine some like terms, then we're done. So let's see. I have an x to the 4th, check. Do I got any cubes? I see a couple cubes. I see a negative 6x cubed minus 9x cubed. That's a grand total of negative 15x cubed. How about squares? See any squares? I see some squares. I see a 10x squared, a 54x squared, and a 20x squared. So if you add all those together, you get 84. So that's 84x squareds. How about just x's? I see negative 90 and negative 120. You add those together, you get negative 210. And lastly, there's just this one stupid number of 200. So plus 200. And that's how you'd go the other way. It would take a long time. I gave you 4 zeros, right? I only gave you 3, right? But the main idea was this: if I give you a complex one, I also gave you its, what's the word when you switch the sign? Conjugate. Very good. And then it's just always x minus it, right? Whatever it is, if it's 4x minus 4, if it's 5x minus 5, if it's a weird thing, x minus the whole weird thing. And then a lot of distributing to clean it up and get back into some kind of form like that. But you should be able to go both ways. If somebody gives you this, you should be able to graph it. You see that 4 and 5 are zeros, right? You could do some long division, and you would figure out that the other 2 zeros are x3 minus I and 3 plus I. Or if somebody says, hey, write something with these zeros, you should know, okay, x minus them are factors, distribute it all out, and then eventually get down to something that looks like the start of the problem. And that's pretty much all I want to talk about today. That concludes Unit 5. Any questions over anything? Nothing? Okay, that's it. So if you want to look at more examples in the book, be my guest. It's kind of the same exact thing I said. I wouldn't even bother. You got all the gist, all that, you'll be fine. So 5.3 is due today, and 5.4, there's the new one, due Tuesday, but it's a good chunk of problems, so you need to get working on that as soon as you can. And again, next week we will come back, hit the ground running with reviewing.